Okay, this lecture is over Module 15 from the CCNA curriculum. It's entitled Application Layer. It might be a little more accurate. It's going to also talk about the session and presentation. So in the TCP/IP model, those are all grouped together in the application layer. In the OSI model, of course, application layer is layer 7. A lot of times these all together, the session, presentation, and application layer are referred to as, quote, the higher layers. But diving into the material, we always start with why should I take this module? And this is to learn about layers 5, 6, and 7 of the OSI model, also known as the upper layers. What will we learn in this lecture? We'll learn about layers 5, 6, and 7, like I just said, the session, presentation, and application layer. We'll learn what peer-to-peer means, talk about that in a little more detail. And we'll talk about some protocols related to surfing the web and sending and receiving email. We'll talk about some services that are related to getting information about or setting IP addresses. And then we'll talk about some services that are intended for transferring files over the network, the particular applications that do that. So 15.1 says application, presentation, and session. I really think it should have the word layers right here because these are 3 different layers of the OSI model. So refreshing our memory, these are the application layers. One layer in the TCP/IP model that equates with 5, 6, and 7 in the OSI. And then what they're talking about is actual applications. And we will talk about some of these applications in this chapter. A few of them we've maybe already talked about, which would be DNS, domain name system, HTTP, which stands for Hypertext Transfer Protocol, SMTP, Simple Mail Transfer Protocol, Post Office Protocol, POP, DHCP, Dynamic Host Configuration Protocol, FTP for file transfer, and IMAP, which is Internet Message Access Protocol. These are protocols that we talk about quite a bit in the different Cisco classes because they're easy to understand, they're very commonly used, and it's good to learn about particular topics related to applications or related to ports that we talked about when we were talking about the transport layer. So 15.1.2 is talking about the presentation and session layer. The presentation layer has 3 primary things. It's responsible for formatting and presenting. That's where the name comes from. The data. If there's any compression of the data, that happens at the presentation layer. And if there's any end-to-end encryption, encrypting at the sender, decrypting at the destination, that's also done by the presentation layer. So down here in this section before we talked about layer 7, we're now talking about layer 6, the presentation layer. And there are many protocols that are used. They give you an assortment here. But this is video video format created by a company called Matroska. So that's a video container that has different video components in there. MPEG, which usually they're MPG files, but when you say MPEG, you usually put an E here because it stands for Motion Pictures Expert Group. They're the ones that got together and created this format for video with sound. You have QuickTime, which is typically a .mov file. QuickTime was created by Apple, and you used to have QuickTime on both Mac OS X and Windows. It is video with sound. And the next three that are shown are image formats. One of the first one was GIF or GIF. People argue over the correct pronunciation of that, but GIF is the abbreviation. JPEG, again, often when you say JPEG, you'll put an E here because it stands for Joint Photographic Experts Group. They're the one that came out with JPEG files. The nice thing about JPEG files were they were smaller in size than a TIFF, which is not even mentioned here. It's one of the first formats, with not very much loss in quality. And then one of the newer formats, the format I really like and that's used on websites a lot, is PNG files. Some people pronounce that ping, but I usually just say PNG for portable network graphics. It's a very small, very nice image format. So those are some of the protocols that you would use at the presentation layer. If we go on down, we talk about the session layer, and as the name implies, it maintains session information between a client and a server. And a lot of times it's an active session. A lot of times if you copy and paste a URL and you go back to it after some point in time, or maybe you email it to somebody and hey, look at this. If that session information is there and your friend clicks on the link, they're going to probably get a message that says something like invalid or expired session, because it knows it's not you actively carrying on a conversation. So that's what the purpose of the session layer is. Now then, at the application layer, we're going to talk about some of those applications or protocols that I mentioned before. Name system is DNS, and DNS will translate domain names into IP addresses or IP addresses into names. It uses both TCP and UDP transport protocols, and it operates on the well-known port 53. So that's some information about DNS. If I click the next button here, host configuration, the one we've talked about down here is DHCP. Prior to DHCP, there was something called BootP. It had a server which ran on port 67, and then clients using this would use port 68. It was based on UDP and was primarily used for diskless workstations to be able to find their operating system and to get an IP address. Over time, BootP has been replaced or superseded by DHCP, which is Dynamic Host Configuration Protocol. Again, it still uses UDP, uses the same ports as BootP, but it will assign IP addresses along with lots of other information that you may get to research in a homework. As far as email, there are several protocols that are used. SMTP servers listen on port 25 using TCP. This typically is when a client sends an email to a mail server. Almost always uses SMTP. SMTP may also be used to move email messages from your email server to the recipient's email server, for example. As far as reading mail, POP has been around for a really long time. It's TCP based and it works on port 110. So you can say, give me a list of my emails. Okay, delete email 3. I want to read email 2. So POP, Post Office Protocol, is one of the another email protocol we use. And then a newer, better for several reasons, protocol is IMAP, Internet Message Access Protocol. It can be used for email. It can also be used for accessing files over the network, but most of the time it's associated with email. It's TCP based on port 143. And like I said, this is usually to, like POP, retrieve email messages from your mail server. File transfer protocol. Back in the 80s and 90s, everybody knew how to use command line FTP because this is the way you downloaded and uploaded software and recipes and all kinds of things over the internet before the web actually existed. A lot of times when we're doing this in class, I go through and it's like SMTP and expect my students to go port 25, HTTP, port 80, FTP, and then they'll answer. And I was like, well, it's really kind of a trick question because FTP uses 2 different ports, port 20 and 21. One of these for controlling what's going on and when you're actually doing data transfer that happens on the other port. There's also a protocol called TFTP, which is trivial FTP. It's kind of a stripped down version, which is meant for uploading and downloading files. It's UDP based and it operates on port 69. The reason we talk about this is used to when we talked about bootp, it would give you a path to get the operating system. Typically, you would use TFTP to pull that operating system down. In the context of Cisco class, doing backups of router configurations, don't think we've talked about that yet, but typically you use trivial FTP to back up or restore your things like your running config file, or your startup config file, different files you may have on your router that you want to keep. And then finally, the web protocols. There's lots of different web protocols, but they talk about the main one, which is HTTP. It's TCP based on port 80. I have a little bit of issue that they put port 8080 here. The correct answer is HTTP is port 80. Now then, if you're testing a web server or you're not able to start a web server on port 80 because well-known ports require administrative access to listen on, a lot of times people will start a second web server on port 8080 or port 8000. So a lot of times that is used, but that's not really the standard. Couple of years after HTTP came out and people wanted to send information securely, like put credit card information, social security number on applications, that type of thing, they came out with HTTPS, and that works on both TCP and UDP based protocol, but it is port 443. And everything between your browser and the web server are encrypted. That's the purpose of HTTPS. Down here, there's a check your understanding. It says application session protocol. My personal opinion is they probably should have kept it in some order. So if this is layer 7, they should have said application, presentation, and then session. The same order that they appear in the OSI model. But they didn't ask me. Okay, talking about peer-to-peer, I can't remember if we have first talked about client-server model, but a lot of times in in-person class, I'll ask somebody, what makes the database server the server? What makes the web server the server? And usually I'll get blank looks, or somebody might go, oh, because it's a great big powerful machine. And it's like, no, that's not really the reason. The reason is the server has the resources. So the database server is the database server because it has the database software to store the different databases and the tables in those databases. The email server is the email server because it houses or has email messages. The web server is the web server because it has the web pages. And then you have a client, which sometimes people will call the PC you're setting at the client, which is okay, but really the client is the software running on that PC. If you're accessing a database, you will have some piece of software like ISQL or SQL Plus that's able to allow the user to type in query or commands and send that to the database server. If you are reading email, you may do that through the web, but you may have an application like Apple Mail or something that's accessing one or more mail servers to allow you to deal with email. In the case of a web server, you're going to use a browser to access that. So that's a brief definition of client server. Now, kind of the contrast to that is peer-to-peer applications. And in computing, when you talk about peers, you kind of talk about computers that are on equal standing, also typically do not have centralized administration. So one of these peers may be your computer at your house, and the other peer that it's talking to is somewhere out on the internet. Do they have to have the exact same specs? No. Do they have to have the exact same software? No. But they're general use computers, again, without centralized control. Here they're showing you that we have two peers or two computers in the same network. And a lot of times when you talk about peer-to-peer network, they're sharing things. And often those things are either printers or files. Peer-to-peer applications are applications. As far as file sharing and print sharing, we can do that over the computers. Peer-to-peer applications are when you are not using the operating system, you're using an application. Here they're showing that a instant message client where you can chat with somebody is a peer-to-peer application. Another thing that might seem a little bit weird, but is often the case, is when you have peer applications, often they will behave as or function both as a client and a server. So common peer-to-peer applications, all the various chat programs would fall in that category, but we've already talked about those. Here they talk about BitTorrent, which is for file distribution. Direct Connect is a file sharing protocol that can be used to write programs for file sharing. eDonkey is a program for file sharing. And then there's something called Freenet, which anonymously allows you to share files, browse and publish what's referred to as free sites. These are sites that are only accessible by using Freenet. You can chat on Freenet forums without censorship. You can kind of think as of Freenet as part of the, what they like to call the dark web. So, maybe nefarious things may happen on Freenet. One of the stats I looked up is peer-to-peer traffic accounts for anywhere from 43 to 70% of all internet traffic. The other thing I usually like to talk about is, is using any of these, we'll pick on BitTorrent, is using BitTorrent illegal? And the answer is, in itself, no. There's lots of file transfers that happen that are not illegal, but, we do have to admit there is a lot of illegal file sharing, sharing music, sharing software for, quote, free, that's violating copyright, and somebody who should be getting paid for creative creation of those materials is not getting paid. But you have to be careful. My daughter, I can't remember, I think maybe she was in middle school, and she did a PowerPoint presentation, and she had some music. And the teacher asked her where she got the music, and she's like, I downloaded it over the internet. And the teacher's like, that's illegal. You shouldn't do that. So my daughter came home a little bit upset, and she's like, my teacher told me this was illegal. And it's like, no, in this case it was not. I will talk to the teacher. And I wrote a note to the teacher and said, just because you download music, yes, I'm not stupid. A lot of that is illegal, but there is legal stuff. You accuse my daughter of stealing music. She actually knows the members of the band. I can't remember if it was Freshman 15 before they were big or if it was one of the other bands she knew, but it's like she knows the band and they gave her that song. So that is not illegal. The artist gave it to her and she downloaded it from their site. Some illegal activity does happen, but it's not all illegal. 10.2.5 is a check your understanding on peer-to-peer computing. As usual, you will do that on your own. We're going to talk in a little more detail about web and email protocols. We'll start up here. Hypertext Transfer Protocol is HTTP. So the HT comes from Hypertext. TP, Transfer Protocol. There's Hypertext Markup Language, which is HTML. I like to teach people to use terminology correctly. So if you tell somebody that you've programmed in HTML, they might get a little bent out of shape about that because it's not really a programming language, it's a markup language. If you said I've written or created HTML, that would be a much more accurate thing to say. Here they're going to talk about the web server process or web page lookup. So step one is the user using a client, which will be some web browser. They will type in http www.cisco.com/index.html. If they left off the HTML, if that points to a directory, which it does, it will assume index.html, or there'll be an order, welcome.html, index.php, etc. But the HTTP is the protocol, Hypertext Transfer Protocol. This next piece after the / is the server name, and then after the server name is the path. So it could say directory1/directory2/index.html. So it's the path from the root web directory to the file you actually want to look at. So the user enters in the URL and then they hit return. And what happens when they hit return? Something called an HTTP request is sent to the server. So basically, it looks up the server name, sends it to the server, and says, hey, I would like a copy of this web page. So what happens in step 3 is the web server looks up the file and sends back something called HTTP response. Now, we deal a lot with this. I used to teach a Perl 2 class. Perl is used a lot for programming CGI scripts on web servers. And we dealt a lot with HTTP responses because usually our Perl program was generating those. And this might be a little picky, but right here in the code between content type and the HTML tag, there should be a blank line. So the correct format of an HTTP response is information about the response and the server it's coming from, blank line, and then HTML code. So there really should be a blank line there. Maybe being a little picky for a network class. And then finally what happens is the client software, your web browser, reads that HTTP response. In this case, pulls out the HTML code, and then it images the web page based upon that HTML code. We talked about this a little before. You have HTTP where the code is not encrypted, or the request and response are not encrypted. You have HTTPS where they are encrypted. When you're interacting with a web server, on the previous page they showed you doing a GET. Here they're showing you do a GET. So this is what the HTTP request looks like. Basically, a GET is, I would like to look at this web page, or I would like you to run this program and return HTML to me. Post is usually sending form data or key value pairs to the web server that would then be used in a script that's being run on the web server is probably the easiest way to explain that. And then when you're uploading a file, instead of doing a GET, you would be putting the file. So you're putting the file from your web browser or your machine to the web server. HTTPS, as I said earlier, is a secure way to do this. HTTP basically uses SSL, which stands for Secure Socket Layer, and it was created in 1994 by Netscape, who used to be one of the most popular browsers on the internet. I suspect a lot of you have never heard of that before. Okay, email protocols. We've already talked a little bit about this, but basically when you send email, usually use SMTP to send the mail message from yours to a mail server at your ISP or your email hoster. It then probably uses SMTP also to transfer that to the receiver's mail service, and then the person reading the mail would use either IMAP or POP to read the email. And I won't go into a lot of detail right now, may not at all this semester, but given the choice between IMAP and POP3, trust me, you should use IMAP if you have that possibility. Here we're going to talk about these in a little more detail. SMTP, Simple Mail Transfer Protocol, it works on port 80, and again, it may send it to your mail server or from your mail server to the recipient's mail server. So this is kind of a repeat of the graphic. POP is intended for somebody reading the email. What they're saying is, if you're sending email, this will be an SMTP server, but if you're reading email, you would be using the POP protocol, or better yet, as I said, using IMAP. So that's kind of the same graphic, except you're using IMAP in this case to read your email. 10.3.5 is a check your understanding on the web protocols and email protocols. So after you feel comfortable with those, you might take this quiz to verify your understanding. 15.4 is entitled IP addressing services. Probably one of the most common ones that we deal with is domain name service. One acronym they mentioned somewhere in this text is FQDN, fully qualified domain name. That is the name of the server followed by the domain, like sweb.uky.edu. It's the full name of the server. Prior to 1983, you had something called the host file, and if your machine was on the internet, all like 2,000 or 3,000 machines that made up the entire internet, you downloaded a file from internet.net, and it had every single computer on the internet with its IP address and its name. I remember downloading that file. You often did it once a week, and it's like, wow, there were 10 new machines added to the internet this week. And then I remember, wow, there were 100 machines added. Wow, there were 1,000 machines added this week. To bring the number up to a few thousand, 5,000 or 6,000. But the internet, like a lot of technology, the servers on the internet or the machines on the internet grew exponentially, and now there's millions and millions of them. So it got where you couldn't keep track. One person or one company just could not keep track of all the new computers, all the computers that got shut down, all the computers that changed names or changed IP addresses. So the problem was solved with domain name service, where an organization was responsible for keeping track of their IPs. So any machine in the world that ends when uky.edu is on UK's campus. A lot of those IP addresses start with 128.163, and we're responsible for tracking every machine in our domain that we want in the DNS server. This is showing you the process of a DNS lookup. So here they're using a fully qualified name. In this case, it's in a web browser. There are other places that you might use a fully qualified domain name. That might be if you're telnetting to a machine, or the more secure, more modern SSH for interactive login would be another place that you might need to use the fully qualified name. So you enter this on the command line, or in this case in a browser, and hit return. And what happens is it does something called a DNS query. So it's going to send a question to your DNS server, which is, I want to go to cisco.com. Can you tell me the IP address? The next step, they're calling step 3, is the actual lookup. The DNS server has databases for IP addresses within the organization. And then what happens is, once it looks up in its database the IP address, that information, along with other information, is returned to the client. And then the last step is the client uses that IP address, in this case, to send a message to Cisco's web server that they want to look at a particular page. So, I want to point out here, they're talking about, in this diagram, it then uses the IP address. So there are 3 pieces of information a computer needs to be configured to communicate. Hopefully these are ingrained into your memory. permanently, but it's IP address, subnet mask, and default gateway. So that's why we are converting the name into an IP address so that we can actually communicate with that server on the internet. The DNS server will return that IP address for us. The next session, it talks about DNS message format. Maybe a better name would be DNS message types. So what happens is what we talked about previous. I have a name, I want an IP address. That comes from something called an A record for address. The other is an NS record, which is going to give you information about the name servers. They have what's called a quad A address. That's an IP version 6 address record. So we know that IP version 4 is 32 bits. IP version 6 is 128 or 4 times as long. So that's why they used AAAA, 4 A's for that. Excuse me. And then another thing you might have on a DNS server is a MX record, which is for mail exchange. So we used to be one of the largest installs of Next computers in North America at UK, and I was the primary system administrator on those machines. We had a mail domain called mik.uky.edu. There was actually no machine named mik.uky.edu. But if you ask a DNS server for that, there was a mail exchange record that pointed it to our primary email server, which I think was madonna.mik.uky.edu, which received and sent mail on behalf of the mail domain mik.uky.edu. There's also CNAME records. If you change the name of a server or want to shorten the name, you can use a CNAME record. There's a few other records that are not mentioned here. This is talking about DNS being hierarchical in nature. So basically you have root level domain, and then under that you have top level domains. So originally there were 7 top level domains: .com, .org, .net, .edu, .gov, .mil. And I always know there's 7, and I always name 6 of them, but the 7th one is .int, which was used for international organizations. So it probably wasn't used a whole lot. Here we have .com, which is commercial. Cisco is a commercial entity, so their second level domain would be cisco.com. And then they don't show it here, but here's some third level domains: www, FTP, and mail. So from the names, this is a web server, this is a file transfer server, and this is an email server. We also, before I go a little deeper into the level domains, I'll stick with the hierarchical or the top level domains. They also had country codes. For example, .cn is China, .us is US, United States, .jp is Japan. Even though there's less than this, there are 255 country codes. I think there's a tad over 200 countries in the world. It fluctuates, but there's some reasons for that. But we had all the country codes. Then at some point in time, can't remember when, they decided to have new domains. And basically, there are a whole bunch of these. For example, .family is intended for family websites. Somebody manages one called .pizza, which I assume they were wanting all the pizza restaurants and chains in the world to use .pizza. I didn't look to see if anybody actually has yet. There's hundreds of those. I may have you look at those at some point in the homework. I will tell a story about the country codes. There was a small island called Tuvalu, and they got .tv assigned to them. They do not have, or did not, at least at the time, have internet access. So somebody paid them $50 million to buy their country code so that you could say, TV show.tv, network.tv. And at one point in time, that was their major source of it was like 10% of their gross national product was the fact that they were reselling or had sold the .tv domain. Okay, going back to the second and third level, which I talked about, this can go on indefinitely. For example, I wrote down skyhawk.ecc.engr.uky.edu. So if we go through that backwards, the .edu says it's an education institution. The second level, UKY, says it's University of Kentucky. The third level, ENGR, says it's in our College of Engineering. ECC says that it's the Engineering Computing Center. And then Skyhawk is a server that they have. So there's an example where you have 5 levels in the domain. But you can do that as deep as you need or whatever makes sense for your organization. NS lookup. If you look at the man page on a Unix machine for NS lookup, I think it says something like to test your DNS server. But most people are going to say just to look up IP addresses. So what happens is if you go into NS lookup, it'll give you a prompt. You type www.cisco.com. It will tell you the name of the name server it is using. It will tell you the IP of the name server. And then it will give you the machine name for www.cisco.com. And then it will give you, in this case, it gave the IP version 6 address and an IP version 4 address. Also told you that origin.www is aliased or CNAMEd to www.cisco.com. If we look up cisco.netacad.net, which is what we used to go to, netacad.net, it will give you the IP address for the netacad.net website. Of course, I don't want to confuse you. We use netacad.com now. This is a syntax checker. Haven't seen one of these in a while. That just allow you to use the NS lookup command. I will probably give you some NS lookup commands to do in upcoming homework so that you can experiment with that. For host configuration, we have DHCP, Dynamic Host Configuration Protocol. Basically, you have servers that supply information. That information is IP address, subnet mask, and default gateway is the most important. But it will also give you DNS servers, which are super important. It'll give you time servers. There's lots of information it will give you. But what they're trying to show you here is where you might have a DNS server. So your ISP you might have a DHCP server. Your multifunction device in your home probably runs a DHCP server. If you're a corporation, you'll have one or more DHCP servers on your network. Here at home, you have a DHCP server. Your ISP is going to run a DHCP server, probably to give out public IP addresses to the routers for their customers. So there may be multiple DHCP servers when you look at the entire network. This is talking about the DHCP configuration. This graphic is incomplete, in my opinion. It doesn't show the tail of the arrows, and it's in the wrong order. So, please make mental note that this is absolutely wrong. What happens is, the first thing that happens is you do have a DHCP request. So a client basically says, here's my MAC address. Does anybody know me and or willing to give me IP addressing information? So hopefully a DHCP server sees that. And then the next thing that comes back from the DHCP server to the client, so right to left, that second box should be DHCP offer. That's basically the DHCP server saying, I'm willing to give you an IP address. Here's your IP address, subnet mask, default gateway, and some other information. How about it? So then the third box should be a DHCP request. Hey, you offered me an IP that you were happy for me to use. I would like to request to actually have that IP address. And then the DHCP server will say, okay, I acknowledge the fact that you're going to be using this network addressing information. I don't really know of any case. I don't know why they have the offer and the request. I'm not sure under what circumstance that the third step of this would be, yeah, I don't really like the IP address you offered, period, or maybe give me another one. Okay. 1548 is a lab that has you observing DNS name resolution, where it's looking up and returning an address. I will be assigning that, so watch for that to appear in Blackboard. I think this is the only lab slash packet tracer out of this chapter. You have a check your understanding on the addressing services we just discussed. So when you're ready to take that, you can take that on your own. And then the last section with new material, 15.5, is file sharing services. The main one we talk about in networking or in Unix networking or Unix operating systems is file transfer protocol, which is FTP. What happens is you have a client. You also have a client piece of software like WSFTP, CyberDuck, Fetch. There's lots of different FTP clients. They create a control connection or an initial connection to the server. And as you're doing gets and lists and change directories, that all happens over the control connection. But when you actually say upload or download data, that happens over the data connection. So that's why we have port 20 and 21. So the control traffic's over the higher number port 21. Anytime you're transferring data, then that'll happen over port 20. In the Unix world, in the Windows world, as far as file sharing, the primary protocol is SMB, which is server message block. Basically, it is file and print sharing. So they're showing you a graphic here. You may be sharing files off this server, or you may be sharing out the capability to send print jobs to the printer. So SMB, as I said, is for file and printer sharing. Usually Unix is criticized for having cryptic names. Usually they're taking letters out of commands, like instead of list you have ls, for example. They did actually go and add letters to this, so they put an A here and on the end. to spell Samba. And so you have a piece of software called Samba, which implements SMB on a Unix environment or a Unix machine. So it allows it to participate in a quote Windows network and do file sharing and print sharing with Windows clients. Here they're showing you with SMB, you're able to do listings and move files from one location to another over the network, like you would with FTP. So we now have a check your understanding on file sharing services that you can do on your own, and then that will take us to the module practice and quiz. What did I learn in this module? Well, you learned a lot of information about the upper layers 5, 6, and 7 of the OSI model. You learned some application layer protocols, so you can read through that just to make sure you remember everything we talked about in Module 15. And then finally, you have the module quiz at the end of the module, which you can do on your own. So that finishes up Module 15. So watch for lecture on Module 16, Network Security Fundamentals, to appear in the near future.